A command pattern is a behavioral design pattern that encapsulates a request as an object, allowing you to parameterize clients with queues, requests, or operations. It enables you to decouple the sender from the receiver and provides flexibility in the execution of commands and supports undoable operations. So that probably makes absolutely no sense. So let's make it make sense by going through an example. So we're going to create a remote control that is connected to a light that can either be switched on or off. So first of all, let's create the light. So this is going to be a standard class with two methods, and it's going to be one method called turn on, and we're just going to log light is on, and then we're going to create another method called turn off, and we're just going to log light is off. Okay, so this is the receiver class. This is receiving from the remote. Okay, and then we're going to create the remote control class. Okay, so this is going to be like our invoker class. This is invoking some command to the light, which is receiving the command. So in here, our remote control is going to store a reference to the light, and we will set the light in the constructor. And then we're going to have a method called press button, so it's going to be a very simple remote with one button for now. And this is going to have one parameter, which is a boolean, and this is whether, if it's true, then we want to turn the light on. If it's false, then we are going to turn the light off. So we're just going to have a simple if statement. So if turn on, then we will call the turn on method on the light. Otherwise, we just turn the light off. And let's now have a look at how a client would use this solution. So in remote control, we pass the light object that we want to control. Okay, and then we can call remote control dot press button, and if we pass true, we should turn the light on, and if we pass false, we should turn the light off. So let's run this program, and we can see that we get light is on and then light is off. Okay, but there actually are some issues with this solution. So in this example, the remote control class directly calls methods on the concrete light object. Okay, so we pass a light object to the remote control, and we are directly calling methods on this concrete light class, because here we can see we're calling light turn on and light turn off. So this direct coupling between remote control and light makes it challenging to extend the functionality or introduce new commands without modifying the remote control class. So for example, suppose that we want to add the functionality to dim the light in addition to being able to turn the light on and off. So if we were to continue with this implementation, then we would need to modify the remote control class directly. If we wanted to add a method to dim the light, then we would need, if we wanted to add functionality to be able to dim the light, then we need to edit this remote control class. For example, we'd create a method called dim light, and we would call light.dimLight, for example. This doesn't exist at the moment, but this is something what we could do. So this actually violates the solid open close principle. and it makes it challenging to extend the functionality without having to modify existing code. And as you've already seen multiple times by now, this isn't ideal. So here is the UML for our current solution. So we have a remote control which is composed of a light object, and it's tightly coupled to this concrete light object because it's calling methods directly that are contained within this light object. So light is tightly coupled to remote control. If we want to add new features, then we have to modify remote control. So let's have a look at how we can improve this solution and make it satisfy the open-close principle so that we don't have to modify existing code to add new features. We can ideally just create some new class or extend our code base. So if we have a look at the command pattern UML, we can see here that rather than having remote control talk directly to the light object, instead we can pass a command to remote control, and then whenever the button is pressed, we can simply call command.execute. And we can see here that this command is an interface. So the remote control is now talking to an interface rather than concrete objects. And this provides us with a lot of flexibility because now we can create multiple concrete commands, and we can pass any of those commands as long as it implements this command interface to the remote control. And the remote control needs no knowledge of the specific command that it is working with. Okay, and then we can see here that the commands have an association relationship to light so that they can interact with the light. For turn on, it just needs to call the light.turnOn method. So using the command pattern, we can decouple remote control. So this is the sender class from the light class, which is the receiver. And then to add new functionality, such as dimming the light, we can extend our code base by adding a new dim command without having to modify the remote control class. So if we created a dim class, we could then in the client just pass this command to remote control without having to modify the remote control. And the remote control is composed of a command, as we just discussed, and the concrete commands turn on and turn off, implement, command, and store a reference to light. So let's implement our remote control and light sort of example using the command pattern. So I've created a new folder called good light, so we're going to use the command pattern here. So this is going to be like a good example. And first of all, we're going to create the command interface. So let's create a new interface called iCommand, and this is going to have a single method called execute. And we are also now going to create our remote control class. And our remote control class, or our invoker class, is now going to store a reference to a command. So it's going to be composed of a command object. And we're going to code to an interface here so that we can use polymorphism. And we're going to pass a command into the constructor. Okay. And then what we're going to do is we're also going to add a set command method. So this is going to allow the client to swap commands at runtime. So we're going to create a public void method called setCommand, and this is going to take a command object. So any command object, any command that implements the iCommand interface, and here we can just set the command. And we're also going to have our press button method. And now all we have to do is call the execute method on the command object, and this will execute whatever command we have passed to our remote control. Okay, so let's now create the receiver or the light class. And this is pretty much the same as we had before, so I'm just going to copy those methods in. So you can see here we have a turn on, turn off, and I've also added a dim method so that we can now dim the light as well. And now we can create our concrete commands, so let's go ahead and do that. So let's first of all create a turn on command, and this is going to implement the iCommand interface. So if we implement this interface, we have our execute method, and what we need to do here is we need to store a reference to the object that we are kind of controlling, and in this case it is the light class. So let's add that in, and then we can pass that into the constructor. Okay, and the light here, this light field, can only be set in the constructor. We're not going to add any setter methods. So basically a command is immutable, so meaning that it can't be changed once it is created. And for our execute method, we can now simply just call the turn on method on the light object. Okay, so let's also create our turn off command. So again, we're going to implement the iCommand interface. Okay, and it's going to be pretty similar to the turn off command. So, the turn on command. And let's copy that in, and we just need to change this to turn off. So we pass a light object into the constructor of the turn off command. And let's also create our dim command. And again, it's going to be pretty similar, but we just need to rename the constructor. And we also need to implement the iCommand interface and call light.dim. Okay, pretty straightforward. So let's now have a look at how a client would use this solution. So if we go into program.cs and create a light, and let's also create our remote. And actually, we don't need to import that. So it's seen here, as you can see here, it's telling us that we need to pass some command object. So initially, I think it's a good idea to actually turn on the light. So let's pass the turn on command, and we also need to pass the light to the command. Okay, and now let's press the button. So if we press the button, we've passed a turn on command. So the remote is just going to execute this turn on command. So let's call the press button. And if we run this, you can see that we get the light is on, so the light has been switched on. And now if we want to say dim the light, so it's too bright, we can call remote.set command, and we can pass the dim command. And then if we press the button and run this, we can see that we get the light is dim. Okay, so we have lots of flexibility now in terms of what command we use, and whenever we want to create a new a command or new functionality for our remote, we can simply extend our code base by creating a new concrete command class without having to touch our invoker class or our remote class. The command pattern is also commonly used in UI frameworks, especially for handling user interactions with buttons or menu items. Each button or menu item can be associated with a specific command object, allowing the framework to execute the appropriate action when the user interacts with the UI element. and this decouples the UI components from the actual operations that they perform, which provides flexibility and maintainability in UI development. Additionally, the command pattern facilitates features such as undo or redo functionality and event logging in UI applications. So here's how a UI framework that implements the command pattern might look. So above this green line we have the framework, and we have a button class which is like our invoker, and this is composed of a command, and you can see the button or the UI component is talking to the command interface, not a concrete command class, and it's also not talking directly to the receiver. So we also have our concrete commands here. So currently we just have an add user command, but we could also have things like delete user or update user, and then this talks to a user service which actually performs the business logic related to adding a user. So the framework would be the code that you couldn't edit. So for example, some UI package, and the app part is the part that you would create, so the custom code, your actual app that you are building. And you would create concrete commands that extend the command interface that is found in the UI package. And your concrete commands keep a reference to a class that contains the business logic, as we discussed, such as a user service, and this contains the methods related to adding, updating or deleting users. So this is going to be maybe interacting with your database. A simpler solution, so if we didn't use the command pattern and we sort of come up with a sort of more obvious solution, and this would be to create a load of button subclasses for each place where a button is used, and these subclasses would contain the code that should happen when the button is clicked. So here we have some sort of abstract button class. This might be from maybe the UI framework, and then our code or in our application we would then create a load of button subclasses where each subclass contains the logic that should happen when, for example, a button is clicked. And the problem with this approach is that we could end up with a huge number of subclasses, and this would be okay if there was no risk of breaking the code in these subclasses every time that the base button class is modified. But if we update our UI library, and that includes a breaking change to the button class, then it could break all of our button subclasses. So this is a very fragile solution. And also, some operations such as copy need to be called from multiple places. For example, a user can click the copy button, press Ctrl+C, or right click and then select copy from a context menu. With this solution, we'd either have to duplicate the copy logic in multiple places or make shortcuts and context menus dependent on buttons, which is a very bad solution. So the command pattern solves this issue by essentially breaking the app into layers, following the good software design principle called the principle of separation of concerns. So the command pattern has broke the app into two layers. We have the GUI and the business logic, and the GUI is responsible for rendering things on the screen, capturing user input and showing results. Then when it comes to the important stuff, such as validating the info from a contact form and sending an email, the GUI delegates that task to the underlying layer of the business logic. So if we have a look at the Gang of 4 UML, you can see here that we have our light class, or our sort of button class. This will be called the invoker class in the Gang of 4 book. We then have our command interface with some sort of execute method, and we usually, I think, have a single execute method in the sort of command interface. Then each command will implement this command interface and have a execute command, and then we have a receiver where the concrete commands sort of delegate the work to this receiver class, and we can see that the invoker is completely decoupled from the receiver, and this provides us with lots of flexibility because we can now use polymorphism to pass different command objects to the invoker, and the invoker needs no specific knowledge of the command that it's being passed. Another advantage of the command pattern is that it gives us the ability to implement undo functionality. So for example, say we have a text editor like VS Code that allows the user to highlight some text, then the user could click a button and make some text in the HTML document italics, which just means slanted. So here we have the UML diagram for implementing this undo functionality. So above we create a new interface called undoable command, which extends the command interface. And this is because all undoable commands are still commands. They're just special types of commands that can execute both forwards or backwards with the execute and unexecute command methods. So why not add the unexecute method to the command interface itself? Well, it's because not every command is undoable. For example, making text italics is undoable, but saving a document or zooming in or out is not. And if you can remember the solid interface segregation principle, it basically states that classes should not be forced to implement methods that they do not need. So it's much better to create this separate undoable command interface. So we then implement these methods in the concrete command classes. So for example, here we have an italic command which implements both the execute and unexecute methods from the undoable command interface. Okay, so we can also use the memento pattern, which we discussed earlier, to implement undo mechanisms. But what's the difference between memento and the command pattern when it comes to undo operations? So with the memento pattern, if you can remember, we store the changes in the state of an object. So in other words, we store multiple snapshots of the state over time. And sometimes storing these snapshots can be expensive. For example, videos are large files that take up lots of memory. And in those situations, it's better to use the command pattern because every command knows how to undo itself. So we don't have to store multiple snapshots of an object. For example, think of the resize operation. If a user resizes a video, we only have to store the previous dimension of that video. We don't have to store the entire snapshot of the video object. So here's how we will implement the command pattern with undo capability. So here we have some slightly confusing UML, but we have an undo command, a new class called undo command that we have created to handle all undo operations. So the way this works is that it pops the last command from history and then calls the unexecute method on that command, as all commands know how to unexecute themselves. So this is kind of confusing to talk through and just look at the diagram, so it's going to make much more sense when we go through this in code. So let's do that. Okay, so I have created here an undoable folder where we're going to put our code solution in here. So first of all, let's create a HTML document class. So in this class, this is where we are going to implement our business logic. So this class will know nothing about commands. It's simply the business layer of our application. Okay, so let's first of all create a property for the content of the HTML document, and we will have a getter and a setter, and we'll also include here now a public void make italic method, and this is where we're going to have our business logic. So basically the HTML document knows how to make itself bold. So what we can do in here is we can set the content equal to the content wrapped in HTML italic tags. Okay, like so. So what we will do next is we will create the command interface with the execute method. And we'll also create the undoable command interface, which extends the command interface. And this extends command. Okay, so that means that it gains the execute method from command, and we will also add an unexecute method. And undoable command extends command, which means that every undoable command is actually also a command object. Okay, so next up we're going to create our command history class, which is a class that's going to keep track of the commands that we've applied. So let's create that class called history. And in here we're going to store a list of undoable commands. And we'll just call this commands. And we'll set it equal to a new list. And then we're going to create a push method. So we're going to create a few methods which will allow us to easily interact with the history class. So we'll create a method called public void push. And this is going to take an undoable command. And we can just call commands.add command. And we'll also create a pop method for removing the last item on the commands list. And this returns that last item. So we get the last command from the list, then we remove it from the lists, and then finally we return it. Okay, so we pop it off the list and remove it from the list, then we return that last item. And we're also going to have a method called size for getting the current length of the commands list, and this is going to be useful in another class a little bit later on. So let's create this, and we just want to return commands.count. Okay, so what we're going to do here with this size method is we just simply check that we have some commands in the commands list, and if we do, then we can unexecute them, for example. So that's why we are using this. We're sort of adding in this size method. So what we can do now is we can create our concrete italic command class. So let's go ahead and create a new class called italic command, and this needs to implement the undoable command interface. So let's implement that interface. So we have an execute method and an unexecute method for undoing the command. So we need some fields up here. So we need to store reference to the HTML document. So let's store a reference to that. We also need a field for the previous content. And we'll initialize that to an empty string. And we also need to store reference to the history object. Okay, so we're going to need to create a constructor now to set these values. And what we need to do is we need to pass the history object as well. Okay. And then we can implement our execute and unexecute methods. So when we execute, what we want to do is we need to get the current content in the HTML document and set it to previous content. We can then make the document italic, and we can push this command object, so this command object, onto the history class. Okay, so we are getting the current content from the document, storing it into previous content, we then make the document italic, and then we push this command object onto the history list. So let's do that. So we can say previous content is equal to doc.content, and then we can say doc.make italic, and we are delegating this work to the doc business object. Okay, so we're not doing this work within the command, we're delegating to the document business object. And then we call history.push, and we want to push this command onto the history list. Now for unexecuting, all we need to do is we call doc.content equals previous content. Okay, so we go back to what the content was before we executed the command. So that's pretty straightforward, but we're now going to create a new class called undo command, and this is going to sort of manage all of the undoable commands. So this is going to make more sense shortly, so stick with me. So let's create a new class called undo command, and this is going to implement the command interface. And what we need to do here is we need to store a reference to the history class, and we can pass this into the constructor. So in the execute method, what we want to do is we want to check if the history has any commands in its list. So if it does, then we can pop the last item, the last command off of the list, and then we can call its unexecute method. So let's do that. So we can say if history.size is greater than 0, so if we have any commands on the list, then what we can do is we can pop the last item off the list, and this should be history.pop, and we can say last command dot execute, unexecute. Okay, so we unexecute the command, and again here we are delegating the this undo logic to the undoable command object. So this is going to make a little bit more sense when we actually use this solution. So let me show you how this is used in a client. So first of all, let's create a HTML document. And let's also create our history object. Don't need that. And let's set the HTML document's content equal to hello world. And let's just log what the content is. Okay, so let's run this program, see what we get. And we get hello world as expected. So what we want to do next is let's try and make the content italic. So to do that, we can create an italic command object, and we pass in the HTML doc and the history object. Okay. We can then call the execute command on the italic command. The execute method on the italic command. So let's actually log the content now. So we would expect this hello world to now be wrapped in italic HTML tags. So let's run this and see what we get. And as you can see, it's working correctly. So it's executed the italic command and made the content in the HTML document italic. So the last thing we need to test out is the undo command. So what we can do here is we can create a new undo command. So undo command equals new undo command, and in here we need to pass the history object that we are working with, and we can call undo command dot execute. And then we can log the content. So we would expect the content now to have no italic tags around it. So you can see here that we are back to having just regular text that isn't italics. Okay, so that's pretty good. So you can see here, let's have a look at this undo command. So undo command that we call undo command.execute. So if we have a look at this execute method, we are getting the last command from history. So if we have a look at our history, first of all, we create this new italic command, which is an undoable command, and we call execute. And when we call execute, this command is going to be pushed onto the history class, the history list. And then when we call the undo command, it essentially pops this command that we just executed off of the history and calls unexecute on this command to essentially revert the content to what it was previously. So when should you use the command pattern? So you can use the command pattern when you want to implement reversible operations. The command pattern is probably the most popular pattern for implementing the undo or redo functionality, and it uses less RAM than the memento pattern, which has to back up the whole state of the object. And the command pattern is great when you want to queue operations or schedule their execution, as command objects can be serialized, which just means converting the objects into strings, and then you can store them in databases or send them over networks. Then at a later time, these can be converted back into objects and executed. So what are the pros and cons of the command pattern? So first of all, it satisfies the single responsibility principle, as classes that invoke operations are decoupled from classes that perform these operations. It also satisfies the open-close principle, as new commands can be added to the code base without having to modify existing code. One of the negatives or cons of the command pattern is that code can become more complex as you're adding a new layer between senders and receivers. So if your program is fairly simple with not too many operations, then using the command pattern can be overkill or over-engineering.